Hi, for those of you who don't know me, my name is David Nash, and basically I wanted to tell you a little bit about a project I've been working on. This is the game Lights Out, which you may or may not be familiar with. It was a game created by Tiger Electronics and released back in 1995. And basically the idea in the game is that you've got this setup, you've got this collection of lights that are on. Generally the game starts with all of the lights on, and then by pressing buttons you try to turn them all off. And the way the game works is that every button press toggles the light on the button you press, and also the lights adjacent horizontal and vertically to that light. And so basically what I did is I used Python programming and the Pygame engine to simulate this game. And so here you can see I've got exactly the same lights on. And when I first started the project, basically what I created was just a way to simulate the game. And so you can go in and you can click on things, and whenever you click on a light, it'll toggle that light and any lights adjacent to it. And so you could take that setup and you could try to solve the puzzle by turning off the lights and as you go. And your goal is to get all of the lights off. And then really what I was after is I wanted to create a computer program that could solve these boards itself. And so I then wrote an algorithm that will allow you to click this solve button, and then the computer will go through and solve it itself and come up with a solution. It'll say how many clicks it took to create that solution, and it will also give you a minimal solution. What's the minimum number of button presses that you needed to solve that board? And then once I had that, I decided to try to generalize the game a little bit. Instead of just a 5x5 board, you could choose different sizes. You could choose something that's 4x4 or 6x6, 7x7, or 8x8. You can actually go in and decide which lights are on and which are not. So for example, on a 4x4 board, maybe I want to turn these lights on to start with. And then the computer program will actually determine whether or not the setup you've created is solvable. So if I go and click begin, this particular pattern is not a solvable pattern. It's impossible to turn all the lights off from here. So it'll check that first. 4x4 boards are very restrictive. So even if I go in and color some more of these, this is still unsolvable. If I turn all the lights on, it should be solvable. So yep, that'll work. And then I can use my computer algorithm to go look for the solution. There's the minimum solution. And in fact, if you don't want to start with all the lights on, you can also use this random button, which will go and generate a random board that is solvable. And then you can play that game too. So you could say, all right, now I want to try to solve this one. And you can try to work your way through there. I found the solution. So I thought that was kind of fun. You can do it for more sizes. It's the same kind of thing. It'll generate a random board, or you can go in and draw the board you'd like. Maybe in honor of Pi Day, which happened recently, I'd like my pattern to be this pi symbol. And then I can start and have the computer solve. And you can watch it run through the algorithm. And basically what the computer's trying to do is it's running through what's called a light chasing algorithm. So it starts by clearing out the top row of lights using the second row, and then clears out the second row using the third row, and so on. And then once you get down to the bottom, some of the lights might still be on. And if they are, you need to figure out what buttons to press in the top row before you rerun that algorithm. And basically the computer system will learn over time. So as it plays, it'll develop a database of, okay, if I get these lights on in the bottom row, what should I press in the top row to clear it out? So it learns as it plays, and so it'll get better as it goes. But the other thing that I thought was kind of cool here is you can actually verify that the minimal solution works, right? So over on the right-hand side here, I implemented this situation where it will show you the minimum number of button presses you needed. Once it's solved, it'll also re-display the original pattern. And so what you can do if you want to check is you can go back and recolor exactly those lights. So let me recolor that pi symbol. And then I can hit begin, and now the pink lights over here will tell me exactly which buttons to press. So I need to press the top left corner, and then the first two in the second row, and then everything except for the third one in the third row. And you can see those button presses disappearing as I go. Then I need the first three in the fourth row, and then 1, 3, and 6, and then 2, 3, 4, and 6, and now I've solved the puzzle. So I can also go and verify that the minimal solution that I have actually is a solution. And I thought that was pretty fun. I basically learned how to use the Pygame engine a little bit, and got this algorithm running, got the setup to have the computer system learn as it plays. And if you're curious, my plan, you can certainly see the code. I've posted that on my GitHub page. But if you actually want to mess around with this, I'd be happy to share an application with you too. Or maybe I'll put that on my website somewhere so that you can download it and check it out if you're curious. So hope that was interesting. Thanks.